So if I keep folding the number, the paper, right? Double 128 is gonna be 256. Double 256. 512. That is 1,024, right? Now, so at the beginning, we actually took the paper and we started folding in order to see a pattern, right? And we saw that the pattern of the number is doubling, right? So I'm multiplying by 2 every single time. Now, do you guys remember when we were testing if it's linear or quadratic, we had to do the first difference and the second difference, right? If the first difference was constant, what does it mean? What kind of function do I have? Linear. And then if the second difference is constant, that means quadratic. Let's test what happens if I do the first difference here. You guys remember the first difference? y2 minus y1, right? So I'm moving up. So I'm subtracting this minus this, right? So 4 minus 2 is 2. 8 take away 4. 16 take away 8. 32 take away 16. 64 take away 32. 128 take away 64. 256 take away 128. And then so on and so forth. Because I can't. So what I did here, I did the first difference. So I subtracted y2 minus y1, y2 minus y1, y2 minus y1 to get this. Is it linear? No, because my first difference is not constant. So the numbers for the first difference are not the same. Right? They're not the same number. Now I have to try the second difference. Second difference, same thing. I have to subtract y2 minus y1. 8 minus 4. 16 minus 8. 32 minus 16. 64 minus 32. 128 minus 64. 256 minus 128. And then 512 minus 256. Do you see any pattern here? Is your first difference constant? So is it 2, 2, 2, 2, 2, 2, 2? No. Is your second? It's the same as what? So the first difference is the same as the number of layers.
Yes.
And the second difference is the same as the number of layers. It's not constant, so it's not quadratic and it's not linear, right? But there's a pattern here. And the pattern is, as Scott was saying, is that first difference is exactly the same as the number of layers. And the second difference is also exactly the same as my number of layers. Now we're going to test something new. Because it's not linear and it's not quadratic, then we have to test something else. We have to test if it is exponential. Now, to test if it's exponential, I have to find my ratio. The word ratio means something divided by something else. Okay? You see with the first difference we do y2 minus y1. With ratio we do y2 divided by y. Okay? So we're going to go back to the y2. We're going to go back to the originals. And then we're going to do 4 divided by 2. Okay? So 4 divided by 2 is 2. 8 divided by 4. 16 divided by 8. 32 divided by 16. You notice the pattern here. 64 divided by 32. So this is going to be 2 pi cubed divided. Is my ratio constant? Yes. My ratio is constant. Since the ratio is constant, that means I can say that it is exponential, but we're going to talk about this more as we go. We're going to talk about what does exponential mean and how does it look like. Okay? So we know it's not linear because I don't see a constant number for the first difference. We know it's not quadratic because I don't see a constant value for the second difference. But I know that it is exponential because the ratio is constant. Are we okay with that? Excellent. Okay, so we're going to have to plot the number of layers.
The raised constant, what is that called?
So it's called exponential.
Oh.
So therefore the function is exponential. What I mean by exponential is, so let's go back and review. How would a linear function look like? What would the equation look like? Y equals what? Mx plus b, right? Where your exponent is 1, right? Now, that's linear. What would a quadratic look like? Give it to me in standard form. What would a quadratic look like? Where your exponent is 2, right? An exponential looks like this. Y equals a base, which is a number, to the power of x. So now your exponent is the variable. So in this case, the exponent is 1, right? And then the base is the variable. In this case, the exponent is 2 and the base is variable. In the case of the exponential, the base is going to be set, it's going to be a number, but your exponent is going to be the variable. Okay? So for example, if I look at something that looks like this, y equals 2 to the power of x, that's called exponential, because your exponent is a variable. Okay? Are you guys okay with this? Alright. Now, we're going to talk more about this later. Let's go back to plotting the numbers. So we have to plot the number of layers against the number. So you're going to have the number of layers on the y-axis and the number of folds on the x-axis. So I'm going to have to graph this and this. This is going to be on, and this is going to be on the y. Okay? Let's do that. I'm going all the way to, I don't need to include all of them because if it's a little too high up right here. So I'm gonna try to fit at least the first 7 points if I can.
How would you graph that? Would you just put each number so it would be just very close to each other?
We're gonna, so if I go, 1 second, 1, 2, 3, 1, 2, 3. So if I go 50, it's not gonna be 100% accurate because I won't be able to fit everything. This is about 100 and this is 100. So I'm choosing this scale, okay? Why did I choose this scale? Again, I'm not gonna be able to fit these points because these are way too high up, right? 256 and 512 and 1024, that's way too high up. So I'm gonna include as many points as I can. And again, they're not going to be very accurate. And this is 1, 2, 3, 4.
So on the test, as long as you're showing that it's a constant, then you're good?
As long as, like, when you're graphing, you mean? As long as it's kind of accurate. But it's not going to be 100%. You know what I mean? You'll see what I mean. Sorry, number of phases. So this is 50. The middle right here is 25. Now I want you to look at this. This is a piece of paper that I started with. Without folding it, how many faces do I have? 1, right? So without folding, with 0 folds, I have 1 face, right? With 1 fold, I have, with 1 fold, how many faces do I have? With 1 fold, when I fold it once, how many faces do I have? 2. So it's going to be a little higher. With 2 phases, how many folds do I have? 4. So a little bit higher, 2. With 3, how many do I have? 8. With 4. With 5. 32. So 32 is about here, maybe. With 6. So 50, this is 75. So 64 is about here maybe. With 7 I had 128. So if this is 125, so it's above them. You see how I'm kind of like putting them where they should be. Okay? So if I'm going to graph this, if I'm going to connect the dots, this is how my graph is going to look. Remember, a linear graph looks like this, right? It's a straight line. Quadratic graph, how does it look? Parabola, right? Either opening up or opening down. Right? Does this look like any of them? No, right? If I'm gonna actually extend this, which I can't extend it here because I don't have negative folds, right? I cannot go -1 fold, right? But if I actually want to extend this, it will be horizontally going this way. Okay? It's gonna get close to 0. I'm never gonna have no paper. I'm always gonna have a piece of paper. Actually, if you want to think about it as negative folds, so let's say if I take this paper and I rip it once in half, how much do I have left? Half a paper. Half a face, right? If I rip it again in half, how much do I have? Quarter of a face. If I rip it again in half, how much do I have? 1/8 of a face. If I rip it again, I have 1/16 of a face. So even if I keep ripping it, yes, I'm going to get to a piece that's very, very small and it's going to be microscopic. But even if I keep ripping it, it's going to be even smaller and a smaller and a smaller and a smaller and a smaller piece. I'm never going to have no paper at all. It's going to be, I'm going to get to a point that's very small that I can't see it, but I'm gonna still have a piece of paper somehow. Okay, so that's why it's never gonna be a 0. It's gonna get close to a 0, and that's why we draw a line that's horizontally kind of with the x-axis. Okay? Okay. Are we okay with this? So describe how the number of layers changes as the number of fold increases. What's happening to the number of layers? Multiplied by 2, or we call it double.
Yes. I used to work with them.
So we see that at the beginning it was growing slowly, but then at the end, when I got to the hundreds, right, I went from 128 to 256 in one jump, in one fold, right? And then from 256, I went to 500 and something in another fold. So it's kind of like growing fast at the end. At the beginning, it was growing slow, from 1 to 2 to 4 to 8. So it's a slow growth. But then, boom, it kind of went fast after. I've already did the first and second difference. So what did we notice about the first and second difference? They're the same as the y values, right? So it's repeating it, it's repeating. So they're not constant, but they just grow like the y values do. I'm going to go back and look at the table of values. Tell me what's happening to the x values. Look at the x values, so the number of folds, what's happening to them? Going up by 2, okay? Now I'm going to look at the y values and tell me what's happening to the y values. They're doubling, they're being multiplied by 2, okay? So let's write this out. So the x value pattern goes up by 1. The y value pattern multiplied by 2 each time. Remember how I told you that an exponential function looks like y equals base to the power of x? You guys remember that? When I said that an exponential function looks like this? Right? Now that base, do you know what would I replace the b with in this case?
2.
2. y2? Because I'm multiplying by 2. Okay? Because I'm doubling, my base represents my ratio. Okay? So in this case, the base is 2 to the power of x. Okay? If your ratio was 3, then your base is going to be 3. If your ratio was 5, then your base is going to be 5. Okay? Now, we already did this, so calculate the common ratio in the table. We've already done the common ratio, and we did the ratio is equal to y2 divided by y1. We've already done that. And what did you notice about the first ratio? It was constant. Okay, so what we're going to do here in this table, we're going to recap the 3 different functions that we have looked at. Basically, starting from grade 9, 10, 11, and 12, we looked at these 3 functions. Okay? So first, we looked at the linear functions, we looked at the quadratic functions, and now we're looking at the exponential functions. What would the equation of a linear function look like? I just reviewed that with you earlier. Y equals mx plus b. In the table of values, which thing is constant? When I do the table of values and I do the first difference, second difference, and the ratio, which one would be constant for linear? The first difference would be constant for linear. And the graph would be a straight line. What's the equation of a quadratic relation? So it has a degree of 2. What in the table of values constant? Second difference. Should probably write a constant. And then it has a shape of graph. What's the equation of an exponential function? Power of x. In the table of values, which one is constant? The ratio. And remember, ratio is when you divide y2 over y1. And it would be, the graph is going to look like this. So it's going to be horizontal from one side and then increasing fast on the other side. There's 2 different ways that you can graph it. There's actually 4. So this is 1. This is increasing. You can also have a decreasing function, so it will be decreasing fast and then slowing down after. Okay? So you can see different kinds of exponential. With the exponential, it has to be almost horizontal on one end, and then either decreasing or increasing fast on the other end. We're going to look at the type of functions, and then we're going to decide if it's exponential, linear, or quadratic. What can you tell me about the first one? Why is it exponential? Because the exponent is a variable. right? The exponent is a letter. So it's exponential because the exponent is variable. So you have a variable in the exponent. What can you tell me about the second one? Quadratic degree. Can you tell me about the last one? Linear degree. So now we're going to use the table of values. Okay, so they gave you the values of x. They gave you where they want you to plug the x. So you're going to find the y values. And then you're going to find your first ratios. And then we're going to decide if it's exponential or not. Okay? So if I plug in 3 to the power of -2, what do I get? It's 1 over 9. Do you guys remember yesterday when I said if you have a negative exponent, you split the base? How many of you remember that? 1, 2, 3, 4. Okay, so if I have a negative exponent, that's the same thing as writing 1 over 3 to the power of 2. So you split the base and you make your exponent positive, which is the same thing as writing 1 over 9, because 1 over 9, because 3 to the power of 2 is 9. Are you okay with this? Now let's do 3 to the power of -1. What do you get? 1 over 3?
Yeah.
Three to the power of 0. 1. Anything to the power of 0 is 1. 3 to the power of 1? 3 to the power of 2? You guys know where I'm getting this from? It's from right here, right? They gave me the function. And then the y values are just the answer of this. Now, I want you to find me the ratio. So remember that the ratio is y2 divided by y1. So, on the calculator, you're going to do this. y2 divided by y1. You're going to have to be careful because in this case y2 is 1/3, so you have to put it in bracket and then divide it by another bracket for the 1 over 9. So do that on the calculator. Make sure you put them in bracket, and I want to know what your answer is. So you're going to put bracket 1 over 3 divided by bracket 1 over 9. What do you get?
3.
Did you put it in bracket? So bracket 1 over 2 divided by bracket 2 over 3. You should be getting 3. Okay. Now, 1 divided by bracket 1 over 3. The reason why we're doing bracket is so the calculator knows that I want to divide 1 by all of 1 over 3. Okay, that's why we do the brackets. 3. Okay, now the next we have to do 3 divided by 1. What's 3 divided by 1? What's 9 divided by 3?
3.
Did you expect that the ratio to be 3? Why? That's right. Remember I told you that the ratio is the same as your base. You remember that? In the previous question? Yes. So I knew that the answer was going to be 3. I just had to make you do it on the calculator. You're welcome. Okay? So, is it exponential? And why is it exponential? Ratio is constant. And then we knew ahead of time that it's exponential because of the equation, but they want us to look at the table of values. And then because they want us to do that, we have to do this. We have to do the ratio.
So, since the base on the next one is 1 over 2, then is that your ratio?
That's correct. So we're expecting the ratio to be a half, right? But we have to do the work. We have to show the work, right? So what I want you to do, if I do 1/2 to the power of -2, what do I get? Without using calculator, look at me and tell me. 1/2 to the power of -2. Because it's the power of -2, what do I have to do? Flip the base. So it'll be 2 over
1.
2 over 1 to the power of what?
2.
To the power of 2. What's 2 to the power of 2? So the answer is 4. Right? Try not to use your calculator with these. Okay? Try to. Sometimes math is fun without a calculator. Okay, now I have 1/2 to the power of -1.
I'm telling you to. I don't know what to look at that.
2. So if I flip the half, it becomes a 2 with a positive exponent. 2 to the power of 1 is 2. Now what's 1/2 to the power of 0? 1. Anything to the power of 0 is 1. You can even try it on the calculator if you want, as long as you put it properly in the calculator with brackets. What's 1/2 to the power of 1? 1. Right? Anything to the power of 1 is itself. What's 1/2 to the power of 2? 1 over 4. Right? Remember the rule that we did yesterday is that when it's this, that 2 goes to both of them. 1 to the power of 2 is 1. 2 to the power of 2 is 4. You guys remember that? So that's 1. Now to find the ratio, you actually have to divide 2 by 4. 2 divided by 4 is 1 over 2. 1 divided by 2 is 1/2, right? A half divided by 1 is a half, and a quarter divided by a half is a half. If you actually use a calculator, again, you're going to have to do the brackets. Okay? You have to do 1/4 divided by 1/2, and that should give you a half. You can try it. So, what can you tell me about this? Exponential ratio is the graph and then we're gonna say what type of graph is it? What type of function is it? What does the first one belong to? What function?
Quadratic.
Quadratic, because it has a parabola shape or a U shape. That's right, it's exponential. And I'm gonna tell you what I'm expecting you to write for this, for the reasoning. It's flat on one side, and then it has a fast growth.
Increase.
Fast increase, fast growth. Okay? So flat on one side. In this case, it's an increase, right? It could be a decrease as well. And then growth. I just want to show you something. If I want to graph the previous question, which was the y equals 1/2 x, right? The previous question that we just did. The question, the thing is going to look like this. Okay? It's a decrease, so it starts high up. What does it mean when I have a half to the power of x? What's happening to my function? Is it doubling? It's decreasing by how much? By a half each time. So eyes on me for a second. So what it means, let's say I'm starting with this paper. I'm decreasing by half. That means I am ripping half of it out every single time. Okay? This is what it means when you have a base of half, right? Or think about if you have 100 ants, and then every single minute you're killing half of them. So the first minute you're gonna kill 50, so you have 50 left, right? After that, you're gonna kill half of the 50, so you're gonna have 25 left. After that, you're gonna kill half of the 50, which is half of the 25, which is 12.5. I don't know how you're gonna kill 25. Okay, so this is what it means when you have a base of half. You're halving it. Okay, thinking about this paper again, you're halving it. You're ripping it in half every single time. Do you guys understand that? Okay, we're gonna talk more about the different kinds of exponentials. So